Professor Ashbrook. Good morning. My name is Jaeyeon Lee, and I'm a PhD student from the HCI lab at KAIST. In this work, focusing on efficiency, Professor Ki-hyuk Lee, my labmate Jae-hyun Han, and I explored the design space of the tactile display, which is located on the back of a smartwatch. Various smartwatches came to our lives. However, conventional interactions based on the visual display is limited because of its small form factor. There are many approaches to solve this problem. We thought that a tactile display implemented on the back of the smartwatch can be a solution. Indeed, the wrist is considered to be a suitable area for a tactile display because it is always in contact with a watch. Realizing this possibility, many researchers are studying the feasibility of a tactile display on the wrist or forearm. However, each of the studies conducted in different contexts and explored different design options. To maximize the information transfer efficiency of a watchback tactile display, we consider design options such as tactile type, temporal and spatial patterns, and position of a stimulus. We took an exploratory approach because there were too many design options. We made a 3x3 watchback tactile display prototype. You can find detailed information in the paper. To compare the effect of the factors, we made 4 directional patterns for each condition. We asked each participant to verify the direction of the randomly played patterns. With the collected answers, we calculated the accuracy and the information transfer efficiency for each condition. To determine the effect of the watchback tactile display efficiency, we categorized the tactors in research into 2 types, surface type and tip type. Surface type tactors propagate vibration through the surface of the tactor, while the tip type tactors do with a tip extrusion. Also, we compared 2 spatial patterns in a trade-off relationship, line and point patterns. We made 2 types of tactors. For a surface type tactor, a linear resonant actuator was used without any customization. For a tip-type tactor, we drilled the surface of the linear resonant actuator and attached a cylindrical tip on the moving part of the actuator. Now let me show you a video clip of the tactor movement. The second independent variable was spatial patterns. Because more tactors were activated at once, the line patterns have the higher perceived intensity. On the other hand, point patterns generate more localized stimuli. As a result, the tip-type tactors showed better accuracy and efficiency than the surface-type tactors did. Line and point patterns did not make difference. Based on the result, we proceeded the next experiment on the tip-type tactile display. By using sensory sortation, the sensation of the lower number of tactors were comparable to that of the higher number of tactors. We wanted to know if the sensory sortation could affect the performance. And we examined the same spatial patterns again because we could not determine which one is better than the other. We compared 2 temporal patterns of presence and absence of the sensory sortation. To make the sensory sortation, tactors were activated twice in the same location with a half-time interval. As a result, with the sensory sortation, the performance was better than that without sensory sortation. We could not observe any difference between line and point patterns. Based on the result of this experiment, we undertook the next experiment with temporal patterns in the sensory sortation. From the former experiments, we could not find statistical difference between the 2 spatial patterns. However, we could observe that the perceived intensity of a stimulus on the outer area of the wrist was stronger than that of the same stimulus on the central area on the wrist. To examine the effect of the locus of a stimulus, we defined two additional spatial patterns. For us, horizontal directional patterns, leftmost and rightmost patterns are the same with the point patterns. For vertical directional patterns, each of the two patterns uses the leftmost or rightmost column instead of the center column. We compare these two patterns with line and point patterns. As a result, the leftmost pattern showed the best performance. Rightmost point and line patterns followed. Statistically, the locus of the stimulus had a meaning, and only the difference between line and leftmost patterns was considerable. Through the experiments, we learned that the tactile type, sensory sortation, and locus of a stimulus can affect the performance of a watchback tactile display. Based on our findings, our recommendation for an efficient watchback tactile display is to employ tip-type tactiles, temporal patterns with sensory sortation, and point patterns on the leftmost outer area on the wrist. Though we found a best combination in the experiments, still our work has several limitations. We predetermined some design options and explored only a few factors. We did not try to normalize other factors in comparison, like the perceived intensity in sensory sortation condition. Thank you for listening.
I'm Matt Jones, Feature Interaction Technology Lab in Swansea. Thank you very much for your work. I just wondered, have you thought about how your findings would change depending on the type of information you want to convey or the context of use? So in certain situations, it might be that the tip point for certain types of information is very valuable, but for other types of information, very unsubtle.
Yes, I think that is a good idea, but we have focused on the efficiency of the tactile display on watchback. Thank you for your question.
Hi, Seung-moon Choi from Postec. I have just one easy question. So there are a few types of different performance measures for information transfer. What was the performance measure you used in your experiments?
Do you mean why why we use the information transfer efficiency in this experiment?
Yeah, so could you explain the definition of that measure?
Yes, I prepared some slide for that. It is like mutual information in communication. If you, for the given stimulus, SI in this slide, the possibility of the response, RJ, is summed in that sigma, two sigmas, and the IT is calculated in bits because of the log 2. So we can find that if IT is 2, then it means 2 patterns can be 2 over 2. 4 patterns can be transferred without errors.
Thank you. How much bits did you have in your experiments for IT?
In the last experiment with leftmost condition, it was above 3 patterns. Above 3 patterns of the 4 patterns.
Let's thank the speaker again.